Archimedes principle. You will find that a elongation of a string or a reading of a balance decreases as the stone is gradually lowered in the water. Okay, whenever we are elongating a string, okay, with a, for example, if it is a stone, okay, or whatever, it is tied with the string and it is elongated, okay, at that time what we are saying, when it is, okay, deep, okay, gradually dipped in the water, at that time what we are saying, that a reading of a balance decreases. What? Okay, reading of a balance decreases. Why? Because at that time when we are gradually deepening means what? Okay, we are putting a stone or a stone which are tied in the given water. Okay, at that time we can see that the mass of a stone or a weight of a stone, okay, mass cannot be changed but weight of a stone, okay, at that time we can see that weight of a stone get decreases. Okay, so from that we can see that from the balance, okay, from the balance measurement we can see that reading get gradually decreases. Okay, however, no further change is observed once the stone get fully immersed, okay, in the water. What do you infer from the decrease in the extension of a string or the reading of a spring balance? Okay, from the spring balance measurement we can see that what we are saying, okay, no further change is observed. Okay, once a stone is gradually or fully immersed in the water, okay, when a stone is fully immersed in the water, okay, at that time we can see that no change can be seen. Okay, but when it was in the rear or a surface of a water, at that time we can see that from in a spring balance a reading get decreases. Okay, so some phenomena can be seen, okay, at that time. Okay, that phenomena which are is the based on the Archimedes principle. We know that elongation produced in the string or the spring balance is due to the weight of a stone. Okay, what we are saying, that elongation produced in the string or the spring balance is due to the weight of a stone. Okay, that we are saying because of whom? Okay, weight of a stone we can see it. Okay, but since the extension decreases once the stone is lowered in the water, okay, whenever the extension, okay, what we are saying, that that is gradually decreases, at that time what we are saying, that a stone, okay, when it is lowered or a dip in the water, at that time extension decreases, means the measurement what we are saying, that it is gradually decreases. It means that some force act on the stone is in a upward direction. Okay, okay, which we are seeing. Okay, once again I am repeating. Okay, we have tied, okay, a stone with a string. Okay, and that string, okay, are tied with the spring balance. Okay, from the spring balance we can measure a weight of a stone. Okay, weight of a stone. Okay, it was readed whatever it was, but when that stone, okay, which are elongated with the spring balance, that are deep, okay, in the surface of water, okay, when it was in a surface of water, at that time we can see that in a spring balance, okay, a measurement are gradually decreases. Okay, measurement which we are seeing, that was gradually decreasing. Okay, that is little bit low as compared to previous one. Okay, so some force, okay, from that we can see that some force are acting, okay, towards the opposite direction. Some force are acting towards the opposite direction of a stone. Okay, stone direction are which direction? Okay, it is in a downward direction, but in a water. Okay, some force are there which are opposing. Okay, which are opposing a stone direction. okay, or a stone force, whatever force is there. Okay, so from that we can see that in a upward direction certain force is exerting, okay, which are opposing a stone direction or a stone force. Okay, as a result net force, okay, from that we can see that a net force on the string decreases. Okay, so net force whatever it will be, they get what, okay, they get decreases. Okay, from the spring balance also we can see that the weight, okay, are gradually decreasing. Okay, so certain force are exiting or opposing. Okay, some force are opposing a weight direction, okay, or a weight, okay, which is one of the force. Okay, and hence the elongation also decreases, and due to which we can see that elongation also decreases as discussed earlier. Okay, this upward force, okay, the upward force which are exerting by the water is said to be a force of buoyancy. Okay, which we said as a force of buoyancy, okay, which we have already studied in our previous lecture. Okay, buoyancy force, a force which are exerting in the water, okay, in the whatever force are opposing, okay, the force which are opposing which, okay, to a stone direction or a stone force, okay, that force, okay, which are opposing is said to be a which force, force of buoyancy, or it's also said as a upthrust, okay, which we say it as a upthrust. What is the magnitude of the beyond force experienced by the body? Okay, now we can see that what is the magnitude of the beyond force exerted by the force. Okay, is it the same in all the fruit for a given body? Okay, do all the body in the given fruit experience the same beyond force? The answer to this question is contained in the Archimedes principle, okay, which we say it as a, okay, so from that we can see that all the fluid do not have a same amount of force. Okay, certain has larger, certain have lower, depending on their density. Okay, it is totally depends on whom, okay, it is totally depends on its density. Fluid of a density, okay, density of a fluid, it can be seen that force are exerting how much. Okay, so now the Archimedes principle. Okay, now we will study Archimedes principle. When a body is immersed fully or partially in the fluid, okay, when a body is immersed fully or partially in the fluid, at that time what we are saying, it experiences an upward force, okay, which we have already studied. Okay, when we are, okay, introducing or dipping a stone, okay, what we are saying in a water, at that time we can see that certain force are there in the water which are opposing a force of a stone. Okay, which are opposing force of a stone, certain force which are opposing a force of a stone. Okay, so that force is said to be upward force, and that is equal to the weight of the fluid displaced by it. Okay, which are depends on whom, okay, weight of a fluid displaced by it. Okay, once again I am repeating what is Archimedes principle. It is most important. Archimedes principle state that when a body, okay, is immersed, when a body is immersed fully or partially in the fluid, okay, when we are introducing a particular body or an object, okay, in a certain fluid, okay, whether it is immersed fully or partially, okay, it will experience what, okay, it will experience upward force, okay, certain force which are opposing a object direction or object force, and that is equal to what, okay, that upward force are depend on whom, okay, it is totally depends on the weight of a fluid. Okay, whatever the weight of a fluid will be there, that much amount of upward force will be exerted, okay, on the object force. Okay, so it is displaced by it. Okay, from that we can see. Okay, this is the statement of Archimedes principle. Now, can you explain why a further decrease in the elongation of a string was not observed? Okay, as the stone was fully immersed in the water. Okay, Archimedes principle has many applications. Okay, it is used in the designing a ship. Okay, it has many applications. Okay, one of its application and some of its application are given. It is used in which, okay, it is used in designing ship and submarine. Okay, submarine and ship, it is used in the designing submarine and ship. Rectometer, okay, which are used in determining purity of a sample of a milk. Okay, how much pure milk is there? Okay, for measuring that, okay, we are using rectometer. Okay, certain apparatus are there which will measure a purity of a milk. Okay, that we say it as womb. Okay, that is said as a rectometer. And hydrometer used for determining density of a liquid. Okay, for measuring a density of a liquid, we are using hydrometer. Okay, are based on this principle. Okay, this is totally based on whom? Okay, it is based on this principle. Okay, once again I am repeating, certain application of Archimedes principle are, it is used in whom? Okay, it is used in designing a ship and submarine. Okay, designing ship and submarine. Okay, lactometer. Okay, which are used for whom? Okay, it is used to measure a purity of a milk. Okay, how much amount of pure or how much pure milk is. Okay, for measuring that purity of a milk, okay, we are using lactometer. Okay, and hydrometer. Okay, which is one of the apparatus to measure a density of a liquid. Okay, so for measuring a density of a liquid, okay, we are using hydrometer. Okay, for measuring a purity of a milk, we are using rectometer. Okay, and also Archimedes principle are used for designing whom? Okay, it is also used for designing ship and submarine. Now, relative density. Okay, so as you know, the density of a substance. Density of a substance is defined as a mass of a unit volume. Okay, now once again, density is equal to what? Density is equal to mass upon volume. Okay, so density is equal to what? Okay, density is equal to mass upon volume. Okay, so density of a substance is defined as a mass of a unit volume. Okay, so from this we can say that density is equal to mass upon volume. Now the unit of a density is kilogram per meter cube. Okay, now how the unit will come? Okay, we know it very well that mass have a unit whom? Okay, it has a unit kg. Okay, as well as many also other are also there, but we will take kg. Okay, mass we have a unit kg, and volume, okay, which are meter cube. Okay, which are what? Okay, it is meter cube. Okay, so from that we can say that kg upon meter cube. Okay, if the meter cube come in a numerator, okay, what we are saying, kg per meter cube. Okay, kg per meter cube inversely. Okay, so this will be the unit of density. So from that we can say that density is equal to mass upon volume, and if we substitute a unit of mass, and unit of volume, we will get kg, okay, inverse meter cube, okay, kg per meter cube, okay. So the density of a given substance under the specified condition remain the same. Okay, what will be there? A density will be same over or a given substance, okay, or a particular substance, okay, whatever it will be, okay, they have its own density, and that density never changes, okay. The density which are there of a particular substance, okay, all the substance have different density, okay, all the substance have different density, but a substance, okay, which are there, they will contain a density, that substance have a density or same, okay, that will be same, and therefore the density of a substance is one of its characteristic property, and it is difficult, okay. So density is equal to mass upon volume, okay, and every substance have its own density, okay, and different it will be different for a different substance. For example, the density of a gold, okay, if we talk about the density of a gold, okay, which is what, okay, 19300 kg meter cube, which is 19,300 kg meter cube, okay, per meter cube, okay. So this is the density of a gold, while the water contain 1000 kg meter cube per meter cube, okay. So you can see that gold have 19300, whereas water have 1000. So from that we can say that, okay, every substance have its own density, okay, and it is totally different from each other, but overall, okay, gold will contain same density, which will be 19300, whether we take a one gold or we take another gold, but both the gold will have a same density, and it will be 19300, okay. It will not change by gold, okay. If we take a one gold, they have a different velocity, second one which have a different, no, okay. Every gold substance or a gold atom will contain a same density, but if the substance are different, okay, for example, one is gold, second one is water, then both of them will contain different velocity, because every substance have its own density, okay. So the density of a given sample of a substance can help us to determine its purity, okay. For determining a purity, okay, it can be used, okay, a density characteristic or a feature. It is often convenient to express a density of a substance in comparison with that of a water, okay. Okay, if we want to express a density of a certain substance, okay, it is convenient to comparing it with whom, okay, with a water, and the relative density of a substance is the ratio. Relative density is what? Okay, it is the ratio of density to that of a water, okay. Density of a substance upon density of a water, here you can see that, okay. If you want to measure, if you want to measure a relative density of a certain substance, then substance own density, okay, upon density of a water, okay. So relative density is what? Okay, relative density is a ratio of a similar quantity, and it has no unit, okay. So relative density will not have any unit, okay. So it will not contain unit. Why it is not containing unit? Because density of a substance, okay, will have a unit what? It will contain a unit kg per meter cube, whereas density of water will also contain same, okay, it will be also kg meter per cube, okay, if we cut, okay. So there will be no unit, So we say it as a unit less. Okay, unit less. Okay, which will be what? Okay, unit less. Okay, so from that we can say that relative density will not have any unit. Okay, so it will be unit less. Now, example 10.7, relative density of a silver is 10.8 and the density of a water is 10 raised to 3 kg meter cube per meter cube. What is the density of a silver in SI unit? Okay, here you can see that relative density of a silver is 10.8. Relative density, okay, is what? Okay, we know it will be what? Okay, density of a silver upon density of a water. Here we want to find the relative density of a silver. Okay, so and here you can see that density of a silver we have to find. Okay, okay, so relative density is given. Okay, so relative density which is given is 10.8 and from that we have to find density of a silver. Okay, now we know it very well that relative density is equal to what? Density of a silver upon density of a water. Okay, now if we take a subject of formula as a density of a silver, then we will get relative density of a silver into density of a water, and we know it that relative density is 10.8 which is given and density of a water is what? Okay, it is 10 raised to 3 okay kg per meter cube. Okay, so we have substitute both of them and from that we will get 10.8 into 10 raised to 3. Okay, so this will be the density of a silver.
Say you have a beaker filled with water and you put your index finger inside it. You'll observe that the water level rises slightly. You put in 2 fingers, the water level rises a bit more. And now when you put in your hand up to the wrist level, you'll see that the water level increases significantly. The ancient Greek mathematician Archimedes observed something similar when he got into a bathtub. When he got in, he realized that the level of water went up. In both the cases, you notice that the water is displaced by the object that goes in. Keep this thought in mind. We'll come back to it soon. In our previous videos, we've seen that when an object is placed in or on the fluid exerts a buoyant force on it which acts upwards. The Archimedes principle goes just one step further in saying that the buoyant force applied by the fluid is equal to the weight of the displaced fluid. We can take a simple example to understand this. Take a 5 kg solid object and suspend it by a spring balance. The balance will read 5 kilograms. Let this be the first case. For the second case, take a beaker of water which has a small opening at the top. The water in the beaker is filled right up to this point where the opening is. And we keep a small container under the opening. Now slowly lower the solid object into the water and you'll see that the reading will be lower number as compared to the previous case. Why is that? It's because of the buoyant force acting on the object. You'd have also noticed that some water was displaced. Now in this context, we can say that the weight of this displaced water is equal to the magnitude of the buoyant force acting on the object. That's the Archimedes principle. When an object is immersed fully or partially in a fluid, the upward force applied by the fluid on the object is the same as the weight of the fluid displaced by the object. Where is this principle applied? Can you think of examples? How do you think large steel ships float? It's simple. If the weight of water displaced by the vessel below the keel is equivalent to the vessel's weight, then everything above the keel will remain afloat. That's because the water too applies an upward buoyant force on the ship, which is same as the weight of the water